Hello, Lounsberry Hollow students. My name is Dr. Kevin Olson, and I work at Montclair State University as a chemist. And one of the things I do at Montclair State is I work for the New Jersey Center for Water Science and Technology, studying water pollution in the state of New Jersey. And I am also Ms. Lally's brother. So we thought that this was a good time for me to get together and share some of my experience and what I know about studying pollution with you, because I'm told that you are soon going to be learning about human impacts on the environment. So let's get started. Now, you're all intelligent young men and women, and I'm sure you read the newspaper, or your parents get the newspaper, or if you don't get the newspaper, you listen to the news on television or the news on the radio, or you have your internet news feed. And if you do those things, you hear the word pollution a lot. What do we mean when we say pollution, pollution, pollution? In the news, we're always talking about pollution. We could be talking about plastics pollution. We can talk about water pollution. We can be talking about air pollution. So what exactly do we mean? What exactly do we mean when we talk about pollution? And very broadly speaking, what we mean by pollution is whenever something that is bad or something that is harmful gets into the environment, it can then get into people, it can then get into animals, it can get into plants, and it can make people or animals or plants sick or otherwise harm the environment. So let's look at a very simple example of just one type of pollution. So let's look at diesel exhaust, which is a type of air pollution. So we have a diesel truck and it's spewing out exhaust, and the exhaust has a number of different pollutants in it, but we can broadly classify them as air pollution. The air pollution accumulates in a city. The air pollution is then breathed in through people's noses, and that air pollution can then trigger an asthma attack, or it can cause some sort of other breathing difficulties for people. So the pollution gets into the air. The harmful chemicals that came from the smokestacks then get into people's noses, which then cause breathing difficulty and require some people at least to use an inhaler. A very simple example of what we mean when we say something harmful in the environment that can cause harm to people or animals or plants or to the environment itself. All right, but if you want to think about pollution like a scientist, we really divide pollution into three very broad categories. And those three very broad categories are air pollution, water pollution, and soil pollution. We can talk about things that are harmful that are in the air, things that are harmful that is in the water, or things that are harmful that is in the soil. Three very broad categories of types of pollution. All right, so let's think about air pollution. So we have, for example, an automobile that is spewing out exhaust. This automobile is supposed to have pollution control equipment installed, but obviously that pollution control equipment is not working. That harmful chemicals are now getting out into the atmosphere. That becomes a type of air pollution. If you've driven to Wildwood or Cape May or the southern New Jersey shore, you may have driven past this coal-fired power plant. And this coal-fired power plant, in the course of burning coal, can discharge certain pollutants, can discharge certain harmful chemicals into the air, so that it's contributing to air pollution. Let's think about the water. Here we have two examples of pollution. We have eroded soil being carried off of the ground, being carried off of the land and ending up in a stream or a river. That is called sediment pollution. Here is an antique or very old sewer system that is unable to cope with a large volume of water, so it is overflowing and discharging sewage into a river. Here on this picture, we have an example of one way we control pollution. It's called a sewage treatment plant. And if your house is connected to the town sewer, your sewage goes to one of these plants where all of the harmful substances are removed and clean water gets discharged out the other side. So what this means is that pollution comes in, harmful substances come in, these harmful substances are removed from the water and clean water goes out, thus preventing water pollution. Now, we also talk about soil pollution. So let's talk about how that happens. Now, here is a picture of an old factory in the city of Paterson. And when this factory was running as a factory, they were using different kinds of chemicals. Some of these chemicals were harmful. And even if the people working at the factory were trying to be as clean as possible, there were still going to be some spills. Some of those harmful chemicals were going to end up on the ground and then end up in the soil. Here is a picture of an illegal dump off in the woods of New Jersey somewhere. I don't remember exactly where this photograph was taken. However, the point is that we have this garbage lying on the ground. Rainwater comes down, washes off any chemicals that were in the garbage. Now those chemicals are in the ground. And here is another type of soil pollution from insecticides. Now you may know the word insecticides from your other science class. It is a chemical that is designed to kill insects. Insecticide, kill, insect killer. When these insecticides were applied to orchards and other crops, anything that was left over, anything that fell down onto the soil can persist in the soil, so that is a contributor to soil pollution. Okay, so if you're going to think about pollution like a scientist, the first thing you need to do is you need to think about 4 vocabulary words. 4 vocabulary words that will help you think about pollution like a scientist. And the first vocabulary word is source. Now, that should be an obvious one. What is the source of the pollution? We looked at a car's tailpipe spewing pollutants. We looked at a truck spewing diesel pollutants into the atmosphere. What is the source of the pollution? The second word is the sink. Where does that pollution end up? So if air pollution winds up in the atmosphere, we would say that the sink is the atmosphere. If something that is in water pollution ends up in a lake, then that lake would become the sink. So where does the pollution end up? That is the sink. Where does the harmful chemical end up? That is the sink. The transport. Well, how does that chemical get there? How does that harmful thing get there? If it's carried through the air, we say it's got windborne transport. It's got atmospheric transport. If it's in the water and is carried through the environment by the water, we say it's being transported by the water. If this harmful chemical is bound very, very tightly to a soil particle, and then the soil particle moves, maybe it's getting eroded by water or rainwater, we say that the transport is by adhering to that particle. And what is the fate? What happens to the pollutant when it gets to the sink? Now, maybe the pollutant will break down into harmless chemicals. We would say then the fate is for it to be broken down into harmless chemicals. Wonderful if it happens. Or it could be bound to a soil particle, and then that soil particle gets buried, and we would say its fate is to get buried. Or we could perhaps that harmful substance ends up inside of you or I, and we would say in that situation, the fate is to end up in a person. So, source, where did it come from? Sink. Where did it go? Transport. How did it get there? Fate. What happened to it? And if it helps, there's an easy way to remember those 4 vocabulary words, and that would be Sammy's soup tastes funny. Source, sink, transport, and fate. Sammy's soup tastes funny. So before we go on, let's just do a very quick exercise, and we'll try to match the source of the pollutant to the sink. Now, I'll give you a list of 3 sources of pollutant: eroded soil, car exhaust, or fertilizer washing off of a farm, and 3 potential sinks for those pollutants: the atmosphere, the ocean, or the bottom of a river. So which of these sources can be matched to which of these sinks? I'll give you a moment to think about that. And while you're doing that, Schnitzel, I'll get Schnitzel the dachshund here, and you could say hello to Schnitzel the dachshund. Yeah, you're a good dog. Okay, match the source to the sink. All right, so we could have eroded soil. You may have heard about erosion in some of your other science classes. Erosion is when dirt or soil that's on the ground is carried away by water, or could be carried away by wind. We say that's eroded soil, or eroded sediment, or eroded dirt. It winds up in a stream. The stream feeds into a river, and that eroded soil settles to the bottom of a river. And we're going to talk about why that's an important type of pollution, or a serious type of pollution, a little later. We talked about the car exhaust. The car is spewing out harmful chemicals mixed in with the exhaust, and the sink is the atmosphere. And before we look at our last example, let me just show you this picture, or these 2 pictures from the city of Los Angeles. In the 1960s and into the early 1970s, the city of Los Angeles was always covered by this air pollution, which we called smog. And most of this air pollution was coming from car exhaust. So in the early 1970s, the country passed a law called the Clean Air Act. And the Clean Air Act required people to have pollution control equipment on their cars. We began installing pollution control equipment on all new cars in the 1970s, and about 35 or so years later, in 2005, look how clean the city of Los Angeles is. So the source of the pollution was car exhaust. The sink was the atmosphere. The fate was just to hang around, polluting the air in Los Angeles. And thanks to pollution control equipment on automobiles, the air is a lot cleaner. It's a good example of how controlling the source of pollution can reduce the overall impact of pollution. All right, let's look at our last example, matching the source to the sink. We put fertilizer on farm fields to help plants grow. The rain comes, it washes the fertilizer off of the fields. The fertilizer ends up in the river. It ends up in a bigger river, ultimately ends up in the ocean. So the source is a farm field where there's too much fertilizer, and the sink is the ocean. And here is a satellite photograph of the Gulf of Mexico. Here is the Mississippi Delta in the state of Louisiana. New Orleans would be somewhere right up around here, I think. Florida is off of this way, and Texas is off of this way. Mexico is down here. But you can see all this green area is the result of fertilizer pollution originating on farm fields farther north up the Mississippi Valley. And the sink is the ocean in the Gulf of Mexico, where we start to see the effects of the fertilizer pollution. Now I'm going to look at a very specific example with you, and that is called stormwater pollution. So what I'd like you to do is say hello to Schnitzel, say hello to the student Schnitzel. I'm going to pause the video, and we'll see you in part 2.